Hello, everyone, and welcome. Thank you all so much for joining today's live stream event. My name is Alexia, and I am the project and event manager of the Microsoft Reactor Toronto. Before we begin, I'd like to quickly review two items with you, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary. Remain professional and on topic. Secondly, our event guidelines. This session is being recorded and will be available on demand through our Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link for our YouTube channel in the chat. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access or interact in the chat. You can set that up now. And if you're unable to use the chat, but have any questions, please feel free to reach out to us through social media or on Meetup. Which brings us to today's session, AutoML in Power BI. We're super excited for the session. I'm going to bring our speaker here. Hello, how are you doing today, Ashraf?
Hi, Alexia. How are you?
Great. Thank you so much for joining us today.
Thanks for having me.
It's great to have you again. I think we're all set up here. Take it away.
Thanks, Alexia. Thanks, everyone. Good morning, good afternoon, good evening, everyone, depends on where you are in the world. And welcome to my session today about one of my preferred topics, which is the AutoML capabilities in Power BI. Before we start our session today, just a quick background about myself. My name is Ashraf Ghonaim. I work as a strategic management and analytics consultant. I have been in this domain for 20 plus years. My background is computer engineering. I also did my MBA in strategy management. I'm also certified in Balance Scorecard, Lean Six Sigma, and PMP. I am the leader of the Power Platform user group community here in Toronto. I'm also leader for the Viz for Social Good at the Toronto chapter. I'm organizer and a speaker in several Microsoft events like MS Build, Power BI Tour, Ignite, Global AI Bootcamp, and Azure Bootcamp. I'm also Microsoft certified MVP, or technically I'm MVP, Microsoft MVP in data platform. I'm one of the 12 MVP in data platform based in Canada. I'm also co-author of the first Power BI MVP book. It's written by MVPs from all over the world, and the chapter I wrote in this book was about automated machine learning and capabilities inside Power BI, which is the topic of our session today. And I'm also the co-author of the first Microsoft AI MVP book. Again, it's written by AI MVPs from all over the world, and the chapter I wrote in this book was about AI cognitive services capabilities inside Power BI as well. Before we deep dive into AutoML capabilities inside Power BI, I would like to go through some key definitions here for those of you who are new to the whole notion of machine learning and AutoML as well. So what is the definition actually of machine learning for those of you who are new to this domain? Is among so many definition, I just picked this one because it makes perfect sense to me. It's the machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. And the key word here, as you see, is the word explicitly programmed. So unlike the classical traditional programming, we don't need to be explicit about the rules and the logic in our code. So in the traditional programming, as you see here, we have the data and we write a program or logic to actually provide output for us. However, in machine learning domain, it doesn't work this way because we don't have to be very, very specific about our rule or logic in the program itself. Instead, we provide the computer with the data and the outcome of the data. based on the historical data, based on what happened in the past. Then the computer itself will figure out the logic and the rules that can be applied in the future for any new future data that never the computer has never seen it before, and then apply and learn from this historical data and apply this logic against the new data that the computer never saw it in the past. And this is the key fundamental shift here between the traditional programming and the machine learning. Let us take a quick example here. So, in the traditional programming, to write a, a code or a program to help us differentiate between what is cat and what is dog, we need to write the rules that can help us identify and differentiate between what is cat and what is dog, based on certain attributes of both cats and dogs. And you can write a very complex piece of logic here with some nested if statement conditions to say, okay, if it has a tail, how long is the ears, the colors, etc. Then based on this logic, you can differentiate between whether this is a cat or dog. That's the traditional programming. And can you see here, it can be very, very challenging, can be very, very time consuming, and there is also a high margin of error as well. However, in the machine learning, we don't do that. In the machine learning, we provide the information based on the pictures already, actual pictures of a cat and dog, and pass this to the computer, and the computer will figure out and extract the logic based on the identified data already, based on the label data that we have. This is a cat, this is a dog, and the computer itself will extract those features from the data or the attributes from the data to help us construct the logic that can help us in the future when we see a picture that we have never seen it before, we can tell whether this is a dog or cat. So the automation process here is the extraction of those features instead of relying on the programmer to come up with these attributes and embed that in his on her own logic of the code. So when it comes to machine learning domain in Azure and particular and Power BI as well, is we are talking about the classical traditional machine learning here. And those are categorized into five major categories. The machine learning in Azure and Power BI help us to answer some key fundamental question about like how much or how many. And this is typically is the what we call it the regression models. Also, is this A, B, or C, which is basically the classification algorithms? Also, how is this organized? And what we call them in our machine learning domain is the clustering algorithms, as well as the anomaly detection. Is this a weird transaction or not? Is outlier transaction for us or not? And the typical use case for that is the fraud detection. So those are the key fundamental questions that a machine learning and Power BI will be able to help us answer those kind of questions. And as you see here with with each type of machine learning, based on the outcome that we are trying to achieve, there are like a set of algorithms associated with each one of those. For example, when it comes to anomaly detection, we are talking about one class, support vector machine, and so on. When it comes to classification, we have several types of classification. Are we talking about two-class classification, or are we talking about multi-class classification? And with each one of those, we have some sort of a certain set of algorithms that we can use to be able to help us answer the classification question. Same like cluster and recommendation, regression, and so on. As you see here, we have multiple algorithms to pick and choose from to be able to answer each one of those questions. So what is the typical process for a data scientist here? Is to get the data, historical data, do some data preparation, then split the data, the historical data that we have, to train the model itself. So we split the data for two sets of data, one for training of the model and the other one for testing. Then the training of the data, we apply the algorithm, again, the trained data. Then it gives us a accuracy score if we compare the result that we get from the trained data against the test data. And when we compare those two together, we can identify the level of accuracy that we have already for this algorithm. And if we are happy with that, we can proceed. If we are not happy, we can try another algorithm, and we keep repeating this process several times until we have the satisfactory score, and this will be considered like the selected model for us. Then we can proceed with deploying the model. So the actual process can be very, very complex, as you see in this picture here, because we can try several algorithms, compare the result of each algorithm, compare that to the test data, identify the score, and compares the scores together, and pick and choose the model that has the highest accuracy score based on the test data. So as you see here, this process can be very, very time consuming. It's still prone to errors because it's dependent on the experience of the data science with those algorithms, how familiar or comfortable this data scientist with those algorithms. And also there are so many factors that can impact actually the accuracy of the final result of the model. That's why we can have some variation from a data scientist to another when it comes to the machine learning model they build. So how AutoML works then? As you see here, there are so many challenges when it comes to building a machine learning model in the classical way. AutoML is taking care of this burden for us and try to streamline the process, automate the process, be very, very thorough, be consistent, and help us to achieve the highest accurate result possible. So how AutoML is doing that? So those are the actually the dimensions or factors that the data scientists need to take into consideration to build their own model. First of all, the data scientists need to understand what features, basically what attributes should be input for to build the data model, because we can have a data set that has thousands of columns. The question is, can those thousands of columns, all of them are relevant actually to help us build the model, or some of them are just noise or not adding any value to the final product or the final accuracy of the machine learning model? This is what we call it feature selection. And it's a big domain in the data science actually to help us identify what are the features that can be relevant to my model and which one should be eliminated because it's just noise and adding distraction to the accuracy of the model. Then the second dimension we take, a typical data science need to take into consideration which algorithm, because as you see here, for each one of those questions, whether it's a clustering, regression, anomaly detection, etc., there are multiple algorithms that we can choose from. Do we need to try all of them? Should I pick a couple of them only? And so on. Then for each one of those algorithms, there are a set of parameters as well. And those set of parameters can also impact the result, the final result, and the accuracy of the model as well. So what should be those parameters that are relevant to this particular algorithm, and even the values for each one of those parameters and the combination of those values together. So as you see, it's a very repetitive process, and it can be very, very time consuming process. And there is so much variation when it comes to the output from a data scientist to another. So AutoML is trying to eliminate that and make the final product is data scientist independent. So it shouldn't the result and the accuracy of our data model shouldn't be dependent on the level of expertise or the skill set of the data scientist, and rather we can automate this process and take this variation from our final output and try to be as accurate or as high accurate as possible. So Power BI, or sorry, AutoML in Azure is doing that piece for us, is trying to understand exactly what are the relevant features that it should be taken into consideration when it comes to building our data model. And also, instead of bothering ourselves which algorithm should I choose, is instead it's very thorough in its process. It actually go through all those algorithms one by one. Not only that, we are, because we have computing power already is allowing us to do that as well, is trying all the parameters and all the values with all the combinations and the parameter itself, and doing that in a very automated, very thorough, very structured way. So as you see here, in one of the iteration, those features were identified as a key features for us with this particular algorithm. Then with those set of parameters, then we achieve certain result here. We don't stop here. Again, because we have very good computing power that will allow us to do this process through multiple iteration and go through those iterations one by one and compare the final result of each one of those iterations, then we can be confident about the one that is achieved the highest score possible here, and we can proceed with that for to deploy the model. So in my opinion, the auto lml is more thorough and more structured, and it can be much faster to achieve results. So after that, we can say, okay, let us proceed with the model that achieved the highest score. And this is what we call it in simple learning techniques, which is basically the process that I explained earlier, and it ranks all the models based on their scores. And we will become more confident about proceeding with the one that achieved the highest rank. So when it comes to AutoML in Power BI, how does this work? Because what I explained about AutoML is just the generic concept of AutoML, how it works in Power BI. I don't want to spend a long time here because this will be done through the demo itself, but just to give you a hint here, it's like very self-service approach. It's taking us through the steps one by one and guiding us through the steps. Based on what kind of question are we asking? Are we talking about classification, regression, forecasting? And when it comes to classification, are we talking about like two-class classification, binary prediction, yes or no, 0 or 1? Are we talking about general classification, which can be more than two values? And also regression as well as forecasting. Then it takes us through the process here to identify what is the data source for us, what is the final output or outcome, a variable that we need to predict, and it guides us through the process here. So we will explain that in the model. And the final output for us here is the the report itself. So Power BI is very transparent about the final result of our model building process, and it gives us all the information that we really need to know about this model, the accuracy of the model, the assumptions, the data set that was used, the number of records, the accuracy model, etc., 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 and will allow us to have much more control over certain parameters we need to adjust based on the relevant business needs before we deploy the model to the new data. So the demo scenario for us today is a very common use case that it is very popular in the data science domain, which is predicting customer churn. So just to give you a background here about this exercise is we have certain attributes based on our data. We assume that we are working in a telecom company and we have certain data. Of course, what you see here in this screen is very simplified version of the data. But let us say that based on the data that we collect about the customer, we have information about the age, the income, education, gender, and then based on the historical data, we have label associated with each one of those customers to tell us whether this customer churn or not. Very simplified version, very simplified data, because in real life scenarios, it can be much more complex than that. So that's the input for us. Then what we really need to achieve now is to build a logic that can be used in the future. If we have a new record that we have never seen before with those attributes, age is 31 and the income is 52,000 and the education level is high and the gender is M, we really need to identify the likelihood. What what is the possibility for this customer to be churn based on what we had already in the past and what we learned about our customer profiles in the past. So this is actually the question that we need to answer using the machine learning model that we are building here. So basically what we really need to do to put a model here, when we have a new record with these attributes, we need to identify the output. The output, don't expect the output to be churn to be yes or no blindly, because there is no mathematical formula or mathematical model that its output is either yes or no. There is no mathematical formula to the result is either yes or no. In a statistics domain, we always talk about the likelihood and the confidence level, which is basically the probability. So it tell us now this is 60% or 60.652% that this customer will it churn? So it's up to us now as a business to determine whether this is to treat that as a churn or not, which is the threshold that we will show later on, how to make this decision to identify the threshold, whether to treat 60% as a churn or not. Should we be more conservative or should we be more generous when it comes to the threshold? Because there are pros and cons, and there is no rule of thumb to tell us what should be the threshold to identify or flag this customer as a churn or not, because it varies from a business to another, from industry to another, and from a situation to another. And there is a cost benefit associated with that as well. And we will explain that in the model. So I hope that can set the stage now for the model. Just to have a quick look here to those questions and see if we have any questions. I think we are good. We're using Power BI now for dashboarding and chart. Or any also using the ML capabilities. Okay, we will see now how the Power BI will be used to actually go through this process here. So I hope this the background for the whole concept of machine learning in general, AutoML as a general concept, as well as the background for this demo is clear to everyone. Let's switch now to Power BI and see how we can use Power BI for this exercise. So, as I said, this is a very common, typical use case in the data science domain. It comes from the data set I use. It's coming from Kaggle, and it's available. It's publicly available data, and it's about telecom customer churn. And just to give you a sense of the process here, is we have a data set with 7,000 records, almost 7,000 records, and we have certain attributes here. As you see, we have gender, whether this is a senior citizen or not, whether this has a partner or not, dependencies or not, the tenure with the organization, and also some information about the services that they have with our telecom company here, whether they have phone service, multiple lines, internal service, and so on. There are so many other columns as well, internal service, online services, and so on. So those are the attributes for us. Then the final column here, if we go through the column here, is the churn. So one of the columns that we have here is the churn, which is the final result, because this is the historical data that we really need to use to learn about the churn in the historical data. So the data, what we call it in the data science domain, is labeled already with the final outcome, which is the churn. So how to use that to train our model now in Power BI? So to do that, you go to Power BI. And start the process here. We need to ingest the data first. We start with that. First of all, this feature is a premium feature. I have to highlight that as well. This is not a free feature. You cannot achieve that in Power BI desktop. It's one of the feature that is associated with the premium capacity. So you have to have either premium capacity across the organization or premium per user at least. And as you see here in my case, there is a diamond associated with that. And the diamond here indicates that this workspace is somehow associated with the premium features and Power BI. And in my case, it's a premium per user. So to start the process, we need to ingest the data first. And we do that through the data flow. And we need to connect that data set for us, link that to our data flow to ingest the data. And just to simplify the process here, I put this data set, same data set in my GitHub profile, and I'll just go here and take the link, the URL for my data set here, click OK, click Next. So as you see here, it's giving me an overview of the data and all the way along to the last column here, which is the churn column. Cool. This is, we are done now with the data that we will be using actually to train our model and build the model based on the historical data. We can proceed if we need to do any transformation steps here. We can eliminate columns, we can replace values, we can do some transformation steps here if needed. However, for the purpose of this exercise and this demo, we'll keep it simple for now, and there is no need to actually proceed with any transformation steps. We will accept the data set as is. Then we can just say okay, save and close. So now the data flow is ingesting the data, is asking me to put a name for this data flow. So I'll just call it reactor churn df data flow and just click save. So now the data is successfully ingested in Power BI data flow. And this screen here, if you have the premium capacity or premium per user, you will be able to access the machine learning models here. And this will guide us through this self-service concept of machine learning to actually go through this process step by step. Let us get started. So the first question here is what is the table, which is the query that I'm using actually here as a data source for us. So that's the churn, the customer churn telecom, and it detected automatically the outcome column, which is the variable that I am building the model to predict. In reality, is you can pick and choose any column because technically you can predict any column based on the other columns. But because of the specific use case that we are going through right now, is what is really interesting for us to predict is the customer churn. But technically, you can predict any column based on the other columns. So we proceed with the churn. Then we proceed with the next step. Then, because of the nature of the output column, which is the churn column, and Power BI already went through all the possible values, and it was either yes or no, churn or not, yes or no. Power BI automatically picked for us the relevant algorithm for that, which is basically binary detection. It's either yes or no or 0 or 1, because we don't have a multi-class classification here in this exercise. So as you see here, it's actually took the burden of even identifying what is the proper algorithm that we really need to choose. And this is the beauty of the automated process here and going through those process uh, through the steps of building the model inside Power BI. So now it's asking me now to, okay, we know that we identified the churn outcome that most interested in. So what we really need to identify now, are we interested now to in the value in the churn column as either yes or no? Which one is more interesting for us? Which one we really need to focus on? So in our case, if the churn is no, I don't have to worry about that. I don't need to bother about it. What I really need to focus on were the cases where the customer churns. So my key output that I'm interested actually to learn more about it, what is driving the customer churn to be yes. Then it's asking me to put some business meaningful labels associated with each one of those values here. So when a customer churn is yes, how do you want to label this one? So basically, it's a churn. I'm just giving some business meaningful value associated with yes or no or 0 or 1, because those are not very business meaningful values. And we will see that in the final report, how those values will be translated into the final report. So in this case, we can change churn, and maybe if it is not a churn, and instead of just let's say not a churn or not, yes, it is basically stay or remain or whatever. Then proceed now with the next step. So as we know that from the data science typical process is the next step is the feature selection. Remember, we said that the feature selection is one of the key steps that the data scientists need to do manually. And this is now Power BI is taking care of this process for us. So it went already through all those columns in my input data set and examined them against actually the final output, which we are trying to predict, which is the churn, and went through those columns and build a quick correlation analysis between this input column, which is the column in the dataset, and the final output. And based on the level of correlation, it makes certain decision whether it should be excluded from the data model or it's actually adding value to the data model. So as you see here, some of the columns were automatically excluded for us and some were already checked in. So the column that were excluded, one of them as an example is the customer ID. Customer ID is not a predictor by all means. It's a unique value and it's unique for every single record. Has nothing to do with the output, whether it's a churn or not. That's why it was smart enough to tell me customer ID has nothing to do with the model. It's too many distinct value and no input or no value to the final outcome, which is the churn or not churn at all. That's why it was automatically excluded. Then gender, it could be relevant to some business and certain industry or not, but based on the data that we have, gender was not detected as one of the possible or potential predictors in my data, because it, based on the algorithm that run behind the scene, it determined already that it's very low correlation between the gender and the churn. So that's why it's suggesting actually to exclude gender from my input. Same as senior citizen, local relation, partner, local relation, etc. While certain values from the customer profile can be a good predictor because it has some sort of correlation between this column or what we call it uh, the uh, uh, the independent variable versus the dependent variable, which is the output or the outcome, which is the churn or not churn. So dependence is can be one of the good predictors. However, Power BI doesn't stop here because it's also giving me the chance now to enforce certain columns. If for whatever reason I feel this is important variable, I need to take that into consideration in my data model, I still can do that. I still can enforce that column to be chosen for me to proceed with the rest of the process to build the model. So, and as you see, the final outcome here, I have no control over it because it's mandatory, it's required. This is my outcome column. So I have no control over that. So I proceed now with what Power BI or the AutoML in Power BI identified for me as possible predictors. Now it's asking me to give a name for this model. So I'll say reactor, churn prediction model. I can provide more description. And as you see here, one of the parameters that I need to identify is the training time. It can take as low as 5 minutes or as high as 36 minutes. What is this driving us? This whole spectrum here is this is actually determine the number of iteration that this process has to go through. The more time you give it, the more it will take into consideration more and more algorithms, more and more feature selection steps, more and more hyperparameters combination, and check that. So if you need to achieve the highest possible accuracy, I suggest to take it to the maximum if time is not critical in your case, or in some other scenarios where it's simple and you really need to get the sense of the data and the accuracy is not 100% driving any serious business decision, you can just go through or reduce that to 5 minutes just to see how the result will look like. Then this is all what you really need to do. So as you see here, in very few steps, we will be able actually to kick off the process to go through the whole automated machine learning process in Power BI. Boom, and that's it. And that's all what we need to do. So I just clicked OK. And now is what is Power BI doing now? The AutoML, if you notice that here in this model, the actor churn data flow is spinning here. And what is doing exactly is going through the automated machine learning process that we explained earlier. Is doing this process here basically. Is going through the features again, the algorithms, try all the algorithms. Features in this case is after the selection, right? But you really need to also examine all those combination of the selected features with all the possible algorithms if the time allows, based on the time parameters that we identified, and also the parameters as well, and score each one of those output. Then we'll pick and choose the model that has the highest accuracy for us. That's it. Will take us for sure 5 minutes because that was the lowest time available. And for the purpose of this demo, we'll skip that part. So luckily I did this exercise already before this session. So we'll proceed now with what I already built earlier before this session to save those 5 minutes for us. So after that, after the model is being built for us and the training is done, the scoring is done, it generates very, very interesting output for us, which is what we call it. If you hover over the action here, first of all, you can retrain the model again if you have new data, and also you can view the report, the output of this process. It generates very, very comprehensive report, and this is very interesting report actually for you to understand more about how the data model was built for us. Very, very transparent and very, very thorough report in my opinion. So let us see how the reports looks like. So it's extracting the information for us to populate the report. So here you go. I started to populate already. Okay, cool. So first of all, let us go through the report one item at a time. The model predicted churn probability for the test data set of 1408 records, and compared the predicted outcome based on the selected threshold to the historical outcome. So it did already the split. It identified the training data set for us, and it tested that against the data set as well. Okay, so what is the model performance here? This is what is really interesting for us. Is one of the key metrics to identify the accuracy of the model is what we call it area under the curve, AUC, and the accuracy for this model is 85%. And you can say, okay, whether this is a satisfactory level of accuracy or not. If I really need to increase that, I have two other parameters as well, either to increase the time based on the time parameters that I pass. So maybe that can help me achieve even a higher or more accurate results. Or I can do some data manipulation, data cleansing. I can go through my data set. Maybe I can replace certain values, blah, blah, blah. So I can do some manual data preparation. And let us go through this process and see if that can help increase the accuracy of the model or not. Okay. Also, it give me very good insights here about the predictors for each for the outcome to be churn, and went through all those columns one by one and put them in the right rank when it comes to as a key driver or key influencer for the final outcome, which is in this case is the churn to be yes. So the first predictor for us was identified as contract is month to month. So month to month was identified. It's one of my columns in the data set and input data set. And the weight for this predictor is 0.33, which is treated as the highest predictor, possible predictor for the customer to be churned, followed by internet services fiber, 0.13, followed by tenure as 0.12. Remember, we are doing here a regression model. It actually helping me actually to build the association now between the independent variable and the dependent variable based on the weight associated with each one of those parameters as well. So I can get more insights about each one of those values in my column. It should populate this chart here. It's spinning. Yeah. So all the values in this column, which is month to month, what are the possible values in this column, which is the contract? Sorry, the column is contract. So the values here, month to month, or 1 year, or 2 year. So as you see here, the majority of the cases when it comes to the churn are associated with or linked to month. Those are still somehow associated, but very insignificant compared to month. How about internet services fiber? I can see all the values when it comes to this column as internet service and see what are the possible values. Fiber is ranked as the highest possible driver or predictor for the churn, followed by DSL and followed by no for this one, and so on. As you see here, we can go through them one by one and see all those possible values, which is great. However, it doesn't stop here, because one of the also key metrics for the binary prediction model like this is what we call it confusion matrix. And I believe they called it confusion matrix because it can be very confusing. So basically, it's plotting those numbers in a matrix where my model is checked against the result of the dataset, the test dataset I have. So the left side here is the actual churn, actually stay based on the values that we have in this dataset. While predicted churn and predicted stay is based on the final outcome from my model that I built here with level of accuracy is 85%. Remember, it's impossible to have a model that provide me accuracy with 100%. Of course, we need to increase the accuracy as much as possible, but if you have a model that this is it's showing this as 100%, I would question actually the accuracy of the model, because that can be a very possible that this is overfitting model, and this is perfectly fit for this particular scenarios, and if you try it in a real life world, maybe it will not give you the outcome that you expected. So it's always almost impossible to have a model that is can be 100% accurate. Therefore, because we know that we have a margin of error if 15%, that is where those two output don't agree with each other, between the actual data based on the test data set and the output of my model. So predicted churn and actual churn, my model and the test data set agree on this number. Predicted stay and actual stay, my model and the actual test data set agree on this box here. However, when they have this agreement is those two values here. When my model predicted this to stay, but the actual data based on the data set is 124, say that the this is actual churn. So we have this agreement now between the outcome of my model and the actual test data. And the actual stay and my model predicted that to churn. So we have to be very, very careful about those two numbers. And this is what we call them a precision and recall. And remember when I told you, you will never have a model, a mathematical model with the final output of the formula to tell you either yes or no. It's always about the confidence level and the probability associated with that. So therefore, Power BI is giving me a nice way here to handle the probability threshold here. So based on the default value here is giving me the chance, if the probability, if you are certain 60% and above, we will treat that as a churn. However, I can control that. I can be little bit certain about that. So I can reduce that to 15% only. And as you see here, it changes the combination of those two values here. The recall started to increase significantly. That means we don't have any disagreement when it comes to predicted stay and actual churn. However, you have to be very, very careful about that, because I predicted so many cases here to churn, while in reality is the actual state. So if I reduce the probability threshold here, as you see here, to a very low limit, that means in my business domain, I will start to target so many flagged customer as a churn based on my model, with either a discount or additional service or something to retain them. However, in reality, they didn't share, because my actual data says that no, those guys don't deserve any discount or any future services or additional services. Sorry, free services, for example, because you actually were so generous about that and they offer so many people who, based on the actual test data, didn't share. So if I become more generous when it comes to the threshold here and increase that to 80%, for example, and above. As you see here, it's flipping the equation completely. Predicted churn and actually stay, 0 cases, while my predicted stay is 370, while the actual churn is based on the data set, this data set, they actually churn. So that means I will miss those guys because I didn't target them with any offer or any discount or any effort from my side as a company to retain them, because my model say no, they will stay, but in reality is they churn. So as you see here, this is very, very critical parameters that you need to take into consideration, and no one can automate that for you because it all depends on the business scenario and the cost associated with the retention of the customer and the churn of the customer. So there is a cost benefit analysis, and takes us to this very critical piece here in our process, which is the cost benefit analysis. So what should be driving actually the actual threshold here? Should be very low here as a threshold, or very high, which is, as you see here, there is an impact on false negative and false positive cases here. What should be driving that is what we call it the cost benefit analysis. So there is always a cost associated with the customer retention and the customer churn, and there is a benefit as well associated with each one of those. So what should be driving actually our decision here about the threshold is the cost benefit analysis. And in the very generic term, Power BI is allowing us to identify what is the unit cost and what is the unit benefit. If the unit cost or the unit benefit is 3 times more than the unit cost, this is how the cost benefit analysis curve will look like. And the optimum point for us is this optimum here, where we have the highest profit margin based on the assumption that the unit benefit is 3 times more than the unit cost. Because if I change those parameters now, you will see it has impact on the suggested threshold. And based on this analysis here, and based on this assumption here, that's why I'm telling you it can vary from a business scenario to another and from organization to another. This is something that cannot be automated because it has to take into consideration the situation in each use case individually. So what's suggested here, the threshold is to be 0.62 as a cutoff threshold between what should be treated as a churn or not. If we change that to 2, for example, the curve started to take a different shape, and the suggested value here could be a little bit different now. So based on this, it's 65 and so on. So as you see, those parameters can have impact on what should be the optimal threshold when it comes to treating this customer as a churn or not a churn. So anyway, once we play with those and we have a conversation with the business, etc., we can say, okay, we will identify the threshold to proceed for us is 65 percent. Let us go with this assumption for now. And this is the result, and we can see the impact actually on each one of those cases. Take that. Okay, however, the report doesn't stop here because it provides me also with more information about the accuracy and how the accuracy was calculated. Uh, and you can go through this. I'm afraid that we don't have time to cover all those details, but this is more explanation here about ROC curve and how it was calculated, etc. The last piece here, which is very interesting as well, is it tells me more information about the whole process here. So the sample number of rows was extracted from the entire data set is 4,404. The training row is 2,996. The final model that was chosen or based in the algorithm for this binary detection case is the pre-fitted soft voting classifier, and the number of iteration that AutoML and Power BI went through to be able to come up with this model is 32 iteration, and it gives me more insights about each one of those iterations and the score associated with each one of those iterations. And as you see here, it picked the one that achieved the highest score within the time frame that we identified, which is the 5 minutes. Again, if we increase that to 360 minutes or 120 minutes, it could achieve better results. You can try that on your own. And also based on the feature selection, those were identified as a key predictor for my data model, those columns. Anything else was treated as not significant when it comes to building the model. So those are what really matters, and those are what my business should focus on. And the parameters we use to build this model is those parameters, and those are the three values associated with those parameters. If you have a data scientist in your organization, they can challenge that if they want, and they can try to see if they can achieve higher or better result than what AutoML and Power BI did. Last step here, which is very last step. So far, we just build a model, right? And we had a conversation about what should be the key value to drive the threshold for us, because this is key fundamental step in our process to proceed with the deploying of the model. Then once we are happy with that result, we can just click on apply the model. And it's now taking me to apply the model to be used against the data that is not labeled. In my previous process, which I did before this session, is I have another data flow that has the data that is not labeled. So I'll pick that, not labeled. I'm not sure which one. Let us be certain here. That's no label. Okay, I'll use that with the no label data. And we can proceed with the threshold that after we had this conversation with the business, this is what we believe is the optimum threshold point. Then I click save and apply. Then it goes against the new data set that was not labeled at all, and it goes through each one of those triggers and predict whether this customer will churn or not. So if we proceed further with Power BI, after the model is applied against new data set, we can go here to Power BI desktop and see how this the new deployed model will look like when it comes to the final result. So we can go here in Power BI desktop and go to Power Platform. Then we use Power Data Flow, Power BI Data Flow. Click Connect. It connects to my tenant. Will give me access to all the still spinning. Yeah. So in the workspace that I chose was a premium per user, and I go here to share data flow. And as you see here, after I deployed my model, it created two additional data flows. Is one of them is the enriched prediction, and the second one is the explanation for that model. So I'll proceed. Just go ahead here and pick those two models after the deployment, because basically what it did, it took this model against the data model that was not labeled at all. It doesn't have a churn even column associated with that, and actually gave us what will be the possible outcome for each one of those columns, whether this customer will churn or not. Then I can do additional analysis here. Okay, so that's all what I need to do now, is to analyze the output of my model. And as you see here, let us go through this quickly. If I go to this data set, which has the model output, yep, it has all those columns again, because those were the predictor. In addition to that, it added a couple of new column. The first one is the churn prediction score, sorry, prediction outcome, this one. then followed by the score. Remember, we said that we have to be certain about the score, and this is what is driving the threshold. So basically, anything that is above 65 will be flagged as a churn. Anything below 65 will be flagged as a false, the true and false outcome. And this is the some additional column here about the explanation for each one of those, and the final one is the explanation index. So that's what I really need to know about the output of this process. So if I can do some more analysis now, let us say the customer churn now to be true or false, then we can associate that with the number of each one of those index as value. So we can see the counts for each one of those cases. This is how it looks like. Then we can do some sort of analysis based on the gender, the contract, etc., etc. So we can do some demographic analysis based on whether this customer will churn or not. So in our case, we really need to focus on what is driving the churn. So we can do some analysis here. One of the interesting output for us is we can do the outcome, and we can use one of the advanced AI powered visuals for us, which is the composition tree, and get more insights about what is driving actually the customer churn for us. So the total cases is 7,800. Let us limit that to the customer churn to be true. So we can flip that to so because this is what we really need to focus on. Then let us see which line of business will be significantly impacted by those churn possible cases. So we can say contract. I don't care about this because I have no control whether this is dependent or not, but let us see what I have control from the business perspective. Contract, device protection, internet service, because those are the things that I can control. Monthly charges, online backup, and so on. So I can add more multiple lines. Note partner, I have no control over that. Streaming TV, technical support, total charges, online security. Then let us see, okay, now let us see what are the most impacted service area in my business based on those possible customer to churn. So I can now go and ask this smart decomposition tree visual in Power BI to highlight for me what are the most impacted area. Remember, contract was identified as the highest possible one. So we are confirming that month to month is the one that is highly associated with the majority of the counts when the customer churn to become true, and followed by, so those guys who lead the month to month contract, you have to be aware of that. Then followed by technical support as no, and so on. So you can keep expanding this and until you see the complete visibility of all the areas of my business that will be highly impacted by this number of customer churn, which is 1927 cases that we flag them as possible churn, and we can get more visibility, complete visibility to which areas on my business will be impacted and those how they are associated with each line of business or each one of those attributes on my in my business. So you can get complete visibility to that and see how even each one is associated with the numbers associated with each one of those values. That's pretty much it. So I hope that can this time was helpful for you guys to understand the whole concept of AutoML and machine learning in general, then followed by AutoML as a concept and how this can be used in Power BI. I just see one question here about NLP and Power BI. So I'm not sure about what do you mean by NLP, but if you are talking about, yes, Power BI has some sort of NLP analysis, and I'm not sure if this is what you refer to or not, but we do some text analytics And we do also in Power BI sentiment analysis score as well, so as well as key phrases extraction and language detection. And to access that based on the data set, we can go here for text analytics, and you will see the list of the services that Power BI can do when it comes to text analytics and NLP. I hope that answer your question. Also, Power BI supports NLP in another way by using the question and answer. So it can actually understand and comprehend your question in plain English language and translate that to a query that can help you to get the answers from the Power BI based on understanding of your plain English language question. So those are the services that we have here under text analytics, which is detecting language in a comment field in your data set in different languages. Also, it can extract key phrases, so it can build metrics based on the keywords and those free text columns, and also identify the score sentiment associated with each one of those comments from 0 to 1. That's pretty much it. Thanks, everyone, and I hope you enjoyed this session. Please reach out to me. I'm available on LinkedIn, and if you have any questions, I would be happy to answer those questions after this session. Thanks again, and have a good day.
Thank you so much for joining us today, Ashraf. We hope to see you or have you again very soon.
Thanks, Alexia. Thanks, everyone.
Bye.
Bye, everyone.